students. This is Dr. GVR Seshagiri Rao, Associate Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So today we will discuss about screw threads definitions and terminology. So what are the important terminology related to screw threads we will discuss. So first of all, you should know fastening types. So how many types of fastenings are there? So it means types of joints. Already in last sessions we have discussed about this classification. So fastening types are two types. One is permanent type fastening and second one is temporary fastening. So it means the types of joints are classified into two types. One is permanent type and temporary joints. So what do you mean by permanent type joints and what do you mean by temporary joints? We will see. So how do you classify? Clear. So in permanent type, in this diagram shown welding, gluing and riveting. So these are the permanent type of joints. Suppose you want to join two plates or two members permanently. So with the help of welding, one possible, another one is riveting, another one is gluing. So these types are called as permanent type of joints. So in these joints, suppose you want to remove any member, any component. So after some working conditions, but you can't replace the member. You can't replace you can't repair the part. So why? Because this is permanent type joints, permanently joined. So you can weld or you can glue or riveting. So with the help of to join two connecting members. So one way is possible, only you have to destroy the assembly. You have to destroy the joint. So it means again you have to replace new one. Clear? So these types of joints called as permanent and it gives more strength when compared to the temporary joints. So advantages and some disadvantages also there. So next one is temporary type of joints. So in this, the temporary joints, threaded fasteners and non-threaded fasteners are keys and pins. So in under threaded fasteners are bolts, studs and screws. So these are called temporary joints. Why? Because if you want to remove, remember you want to separate the joint, so you can easily separate them. So why? Because these joints are joined with the help of a bolt and nut only. You can replace. No need to destroy the joint. Similarly, keys also. In keys, already we have discussed in quarter joints and knuckle joints topic. And pins. These are temporary. We want to connect two coaxial rods or two shafts. With the help of these pin or keys or bolts, you can assemble. You can join. So today's the screw type of joints comes under this temporary joints. So one more joint is also there. That's the couplings. The couplings also comes under this temporary joints. Why? Because suppose if you want to join two plates, two members with the help of bolt and nut. Here one bolt. So these are two coaxial rods. This type of coupling is called as flange coupling. So whenever you want to repair or you want to replace, so you can easily dismantle. Similarly, in the case of key also, to control the key is used to control the relative motion between the shaft and the hub. So here shown some temporary type of joints, the screws. So now a thread application. So what is the importance of thread to hold parts together? In screw threads, in screws, see here threads are there. Here also you can find threads. This part is stud. Both side threaded portion is available. These threads are used to hold the parts together. They are shown in this figure. So part A and part B, these two parts are joined with the help of this threaded screw, the bolt and nut. Here part C also. The second application is to move the parts relative to others. One is to arrest the relative motion. Second application is movement. So between the two parts. So see here woodworking wise, here farm fruit pressing machine, the bench wise, carpentry wise. So this wise is woodworking wise is used to fix the job for different operations. So it means it moves relative to the others. So whenever you want to tightening or loosening with the help of this thread application, you can perform very easily. In farm fruit pressing machine also, same application, you can rotate this lever with the help of threading. Yes, what is the important terminology related to these screw threads? Two types of threads are there. One is external thread, another one is internal thread. You can say the external thread is called as male thread, and the female, the internal thread is called as female thread. Here shown in this figure, the external thread and internal thread. So the thread portion cut in externally on a cylindrical object. Here in this internally, the thread portion is there. So these internal thread is cut on the inside of the cylindrical body. These in case of external thread, the thread cut on the outside of the cylindrical body. This is called as male and female. You can join this nut and this external this thread for different applications. In this again classified into two types: right hand thread and left hand thread. It depends upon the thread rotation. Suppose the clockwise direction, clockwise rotation is possible in right hand thread. So it means the thread will assemble when turned clockwise. So whenever you are rotating clockwise, so then the thread will assemble in that direction only. that is right hand type of thread. So already shown in this diagram. So the movement, the advances, the screw, the thread advances in right to left. Suppose your direction is clockwise direction. Similarly, in the left hand case also, left hand thread. The thread that will assemble when turned counterclockwise. See in this diagram, left hand is shown. So in this, the direction is left hand side direction. So these two are classified and depends upon the direction, rotational direction. So in this diagram shown, the turn buckle. So it use right hand side and left hand side thread at each and two double displacement. So in this case, happened double displacement. So in this case, in the previous case, happened single displacement. That is depends upon the threads also. So I will explain in later coming up slides. Next, other important terms are thread angle, root, and crest. So in this diagram, shown external thread and internal thread. So already we have discussed about external thread. The thread portion cutted on cylindrical component. So here internally cutted the thread portion is internal threaded screw. So in this shown root and crest and thread angle. So this the angle between two threads. This is one thread, 1 and 2, 3, 4, 5 like this. So what is the angle between one thread and another adjacent thread? So this angle is called as thread angle, included thread angle. The root is the bottommost portion is called as root. And suppose if you are drawn an imaginary circle through this imaginary line, that is a root circle. You can draw side view, imaginary circle and outer circle. This one is root circle. Similarly, the tip point, the topmost point is called as crest, the peak edge. One is peak, another one is the bottommost portion. The bottom of the thread cut into a cylindrical body. So here already explained the thread angle is between the threads faces. This is one thread face like this, another thread faces. What is the angle between these two? 2 theta. So like example 2 theta is equal to 45. So like this, how to represent the thread angle, crest and root. Other terms are major diameter and minor diameter. So major diameter shown in this external thread and internal thread also. In case of external thread, the topmost peak edge. So if you draw an imaginary circle through the top edge, through crest portion, that is called as major diameter. If you are drawn a circle through bottommost portion, that is minor diameter. So it means the major is the larger diameter on an internal or external thread. It may be external or internal. So whatever type of thread, but your largest diameter which one is larger. So that is called as major. So minor, the smallest diameter on an internal or external thread. So while measuring, we will take internally in case of internal thread, and external thread externally we will take measurement. Next one is pitch and lead. Another important term. The pitch is the distance between crest of threads. The crest already have discussed. So what is the distance between two crest? Lead is the distance of a screw will advance when turned 360 degrees. It means in complete one rotation. So how much travel from one point to another point in this direction advance. So how much advances? So here pitch means the distance between two thread portions, two thread points. So in this diagram shown, this is crest. So between these two is called pitch. So during rotation, so how much traveled from one point to another point, from one point to another point, like this. So this is called as lead. So the lead is, in case of single thread, the lead is equal to pitch. In case of double thread, the lead is equal to two times of pitch. Why? So here, in case of you take a single thread screw, the lead is equal to pitch means in single thread only the distance travel in one rotation, one complete 360 degrees is equal to pitch distance only. But whereas in a double type of thread, double thread, two times of the pitch. So it takes time to travel to one thread to and a second thread. That is two times of the pitch. So similarly, in case of triple or four triple type threads, multiply with 3. Next one is thread formation, the type of forms. The form is nothing but that profile shape of the thread only. So according to the shape of the thread, again classified into different types of threads. So one is main classification is external thread and internal thread. Another one is right hand type thread and left hand. And based on pitch and lead, that is single type thread and double type of thread. So another one is the shape of the thread, which may be square, which may be acme thread, it may be half circle, it may be round or flat. So already here shown some thread forms are here shown. One is American National, and flat type the threads are available in this, and rounded or flat. The shape of the thread is rounded. So like this. The shape of the thread is suppose like this. So these are shapes of the thread forms. Whitworth, sharp V, square type, and acme thread. So in this square and acme thread, the angle is here perpendicular 90 degrees. But in this case, acme thread, the angle is 45. The angle is 45. In buttress thread, 60. Clear? And a knuckle thread, some radius is available in this case. And example here shown, the application or electric bulb, knuckle type threads. So you can find. So how to represent on a drawing the detailed representation shown. A thread angle, external thread, and internal thread. So always use slanting lines to represent crest and root. So roots and crest are drawn in sharp. So sharp type of edges, then nothing but V's, V type of edge. Shown in this external thread, and the angle also mentioned here, 60 degrees. So it's a metric type thread. So internal threads also shown in this figure. This type of the formation of threads is called as thread runout. Next, schematic representation. The previous one is detailed representation. Next, schematic representation. In this schematic representation, always use long and short lines for representing the peak edge of the thread, and bottommost portion, that is called as the roots of the thread, crest and roots of the thread respectively. So in case of external thread, see in this use long and short lines. So one is long line, thick and short line. The short lines are root, the long lines are crest thin lines. These are it's same. The distance between through threads. Similarly, in case of internal thread also. The root thick line represents a root portion, and long line and a thin line represents crest portion. Next, simplified representation. In simplified representation, use thick continuous lines for representing the crest. So thick continuous lines. See in this diagram shown the thick continuous. Here also shown thick continuous. These are continuous thick lines. It represents crest, topmost portion of the thread. In root, always representing the thread in thin continuous lines. Thin continuous line. So here you can write pitch like this, pitch upon by 2. So this is 0.5 times of pitch. So like this, you have to represent the threads and their terms, pitch or lead or root or crest. In simplified representation, thick continuous lines for representing already we have discussed, and thin continuous lines, but in a sectional views, how to represent the section. In internal thread, the sectional view is shown. This is section portion. sectional lines. The lines, which lines are drawn with 45 degrees for representation. So here, detailed representation, how to represent like this, the angle and then the pitch. In this schematic representation, how to represent root and crest. And in simple bed representation, root and crest and pitch. But only difference is here, thick continuous lines and thin continuous lines have to use for representing these terms, root and crest. The internal thread use with the dashed line. The sectional views with the help of section lines. So all important terms using screw threads shown in this figure. So whatever we have discussed. Here the nominal dia shown the outer diameter of the thread portion. And then pitch with the help of the denoted by P. And then slope and angle of thread. Slope between two threads, and then flank. What is the flank? When you are taking the face of the thread, the slant portion is called as a flank. And then you are calculating pitch. You are mentioned how pitch. Suppose here this one is one thread to 1.2 next adjacent thread distance. The axial distance between these two threads are called as pitch. And here lead is, so how much advancement is there? So that is called as lead. Here in this video shown major diameter, pitch diameter and minor diameter. So here the minor diameter calculated at the bottommost portion, and pitch circle dia and major dia the topmost portion of the threaded. So that is suppose though it is a imaginary circle drawn through crest. So that is called as major diameter circle. You can calculate major diameter, pitch diameter and minor dia. So here explain the major diameter and what do you mean by minor and pitch diameter. So already we have discussed about this major diameter. The largest diameter of an external or internal screw thread. Suppose you are consider external thread. So which one is larger? So that is fixed as a larger diameter. So internal minimum diameter, which one is having? So that is called as a minor diameter. The smallest diameter of external thread or internal thread. And also called as, here as in major diameter, nominal diameter. Shown in this diagram, nominal diameter is called as major dia. Inside you, here mentioned major dia, in the elevation in front you nominal dia. So both are same. So nominal dia is equal to major dia. And similarly minor diameter also called as core or root diameter, minor diameter. Core or root diameter. Next, the pitch diameter. So it is the diameter of an imaginary cylinder. So that is on a cylindrical screw thread. So here the circle pass through the thread at some points to make equal width of the thread. So that is called as uh, effective diameter or pitch diameter. So pitch is the distance between the point of one thread to the corresponding point on the next thread. Suppose threads are like this. So one point to the next point of the thread, or one point here. So distance between these two in axial direction. So measured in an axial direction between corresponding points in the same axial plane. So pitch is equal to 1 by number of threads per unit length of the screw. That is pitch. You can represent mathematically like this. It is the lead is distance between two corresponding points on the same helix. It may be defined uh, as the distance which a screw thread advances axial in one rotation of the knot. So how much traveled from one point to when it is in rotational motion? Suppose screw thread in rotational motion, how much traveled from one point to another point? The distance, measured distance is called as lead. Crest already we have discussed the top surface of the thread. The bottommost surface is called as root, that is created, the surface created between by the two adjacent flanks of the thread. The flank is the surface which surface is joining the crest and root. So in this diagram shown here crest and root, the flank. The surface with joining surface between this crest and root, that is called as flank. The angle of thread, the angle included by the flanks of the thread. It is the half the pitch of the thread slope. So in this angle of thread, angle included by the flank surface. So here shown flank, and this is one flank surface, another flank. So what is the angle between these two surfaces? It's called as flank. An angle of thread included with these two flanks and the slope. It is the half of the pitch of the thread. So next one is some forms of screw threads are there. Here shown one type of thread, isometric thread. Here the thread assembles occurs if and only both internal and external thread. So when it is possible, whenever an equal nominal size and pitch. So then only the thread, so whenever having the equal nominal size diameter. So in this case, in metric type thread, the angle, the thread angle is 60. Here shown internal thread. These blue lines are showing representing internal thread, and these lines are representing external threads. So so already what is difference between these two internal and external thread. So different types of thread forms are there. Is metric thread, acme thread, Whitworth thread. So these all are classification of threads depends upon their thread angle. So here in this case the angle is 60 and the pitch is sorry that slope is p by 8, that is that distance between two crest portions. Here in case of internal thread p by 4 and the center 1.2 another point of the thread is called as pitch. So here shown center line of a threaded assembly. So how to designate designate the threads. So the designation of screw threads are size designation and tolerance designation. So always the size of the screw thread is designated by the letter M. M example M8 and M16, M10 like this. You have to give designation. For a particular screw thread. So here the letter M followed by diameter and pitch. 16 by 2, 18 by 1.5, 10 by 2.5 like this. So the two being separated by the sign X shown in this example. So when there is no indication of the pitch, it shall mean that a coarse pitch is implied. Suppose there is no pitch, so directly you can take M10, M16 like this. So tolerance designation, they shall include a figure designating tolerance grade as indicated. One is 7 for the grade and 8 for the nominal medium grade and 9 for the coarse grade. This is the standard tolerance grades. 7 for used for fine grade, 8 for nominal grade, 9 coarse grade. So a letter that is suppose here taken H for unit thread, D bolt thread, you are using H, so it indicates it is for unit thread. So for you are giving like this tolerance D for bolt thread with allowance plus 0. Plus or minus 0.02 like this. H for bolt thread without allowance, small h. So like this, how to give designation to a screw threads. For example, here shown a bolt thread of 6 mm size of coarse pitch and allowance on the threads and nominal the medium type tolerance grade designated as M680. So here the first letter, the letter M designating the metric thread. And the 6 size is the coarse pitch. Here by the diameter and the pitch, them followed by the diameter and the pitch. 6 size, so diameter 6 and coarse pitch 8. And the tolerance grade is designated as like this 8D. So D here used, it means the D is used for a bolt thread. So if you are used here small capital H M6 8 small h. So it means the small h is for bolt thread without elements. Suppose here M10 5 capital H. It means a bolt thread of 10 size of coarse pitch, and with allowance of the threads and tolerance grade is here H, that is unit thread. This is for unit thread. So like this you have to designate the screw threads. Next, what are the stresses induced in the screw threads when it is in screwing up or screwing down or up? So initial stresses induced in the screws due to this tensile load and a compressive load. So first one is tensile stress due to the stretching of bolt. So initial tension in a bolt based on experiments, the standard relation is found, that is Pi is equal to 840D. Here shown the Pi is initial tension in a bolt, and D is the nominal diameter of the bolt. So by using this relation, you can find the initial tension in the bolt. Next one is torsional shear stress. So caused by the rotational motion, so that is frictional resistance of the threads during its tightening. You have to use torsion equation. T by J is equal to R by tau. So you know the T is torsion and J is polar moment of inertia, that is 5 by 32 to dc cube is equal to R by shear stress. So by using this relation, you can find the shear stress is equal to T by J into shear stress is equal to R multiplied with 5 by 32 into dc cube divided by T torsion. So again you can write in place of R dc by 2 5 by 32 dc cube by T, so that you can write 5 by 32 in this R is equal to 5 by 32 into dc cube. So you can substitute here dc by 2. So we'll write clearly. So the final equation you will get shear stress 5 by 16 into DC cube T is equal to pi by d into shear stress. So you can find 16T shear stress 16T by pi d DC cube core diameter the DC. Similarly, the shear stress also induced across the threads. So how do you calculate the shearing stress for the screw? That is TS shearing is obtained by using this relation. P pitch by pi DC into B into N, where B is width of the thread section at the root. Shear stress is equal to load pi DC into B into N. So average thread shearing stress for the knot you can calculate by using this relation. Here D is a major diameter. This is for a nut. In previous case for screw. The fourth one is compression or crushing stress. So crushing stress induced between the threads. So you may calculate the crushing stress by using this formula, load upon area. So area is area multiplied with n is here number of threads, and the area for crushing, okay, this area is crushing area. In previous earlier first case shearing area we have taken. So take here crushing area as pi into d square minus dc square whole square. So d square is major, d is the major dia and dc is the minor dia. So substitute those values, you may be calculate compression or crushing stress of the threads. Next, one more important the stress also induced in the screws, bending stress. So this bending stress will be induced the surfaces under the head are not so the nut and head surface are not perfectly aligned, that is parallel to the bolt axis. Not aligned with the bolt axis, then the bending stress will be possible. So it means that bolt subjected to bending action. So how do you calculate the bending stress? The bending stress induced in the shank of the bolt. So already you know the shank portion. This is threaded portion. This one is shank. This is threaded portion and head. So by using this relation, you can calculate the bending stress. Say where here x is the difference in height between the extreme corners of the knot or head, and length of the shank. What is the length of the shank L? And E, you know, that is Young's modulus for the material of the bolt. That is Young's modulus depends upon the bolt material. So substitute those values in this equation, you will get the bending stress. So up to now we have discussed stresses due to the initial internal forces, the stresses due to the external forces. So in this case also tensile stress will be induced. So actually the studs or bolts or screws carry a load in the direction of the bolt axis only. So suppose take like this bolt, so bolt direction is axial direction. So in this case, you can calculate the shear stress, the tensile stress is equal to load upon area. So how do we calculate the area? So take the core diameter of the bolt, DC by DC. So you can calculate the load by using this relation. DC is root of core diameter. Sigma T is permissible shear tensile stress. So load is external load when it is subjected to external load. Similarly, shear stress when it is subjected to shear load. The shear load is equal to 5 by 4 to d square tau into n. So here you can calculate the diameter of the bolt by using this obtained relation. So whenever it is subjected to combination of these two, tension and shear, combined stresses. So here you have to use the maximum principal shear stress and the maximum principal tensile stress theories. So maximum principal shear stress, so already we have discussed about this relation in earlier sessions. So of into square root of sigma t square plus 4 tau square. So here maximum shear stress, shear max, and sigma t is the tensile stress and shear stress. So by using this relation, you may be calculated the maximum principal tensile stress, sigma t by 2 plus of sigma t square plus 4 tau square. So I have taken references V. Bandari, R.S. Kurmi, and R.L. Nath. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.